All right, so you sent over some really interesting stuff on AI,
Mm-hmm.
particularly on state space models and attention.
Yeah.
And it's like we're kind of peeking behind the curtain of how machines learn to predict and understand sequences.
Right.
Things like text, music, even financial markets.
Yeah, it's a really exciting area of research. And
Yeah.
and the paper you shared, structured state space duality, is really pushing the boundaries of what we thought was possible.
Okay, so I'm getting the sense that these two approaches, SSMs and attention, have been kind of like separate camps in the AI world.
Mm-hmm.
What's the traditional view of their strengths and weaknesses?
Yeah. So for a long time, SSMs were seen as the efficient workhorses.
Okay,
Think of them like a super organized note taker who condenses information without losing the essential flow.
right.
They're great at capturing patterns and making predictions based on what's come before.
So they excel at spotting trends and forecasting.
Exactly.
Where does that leave attention? What's its specialty?
So, attention is more like a detective scanning a scene for crucial clues.
Okay,
It can zero in on the most important parts of a sequence, even if they're far apart, to understand the big picture.
got it.
It's fantastic for tasks that require deciphering complex relationships within data.
So we've got the efficient note taker versus the insightful detective.
Yeah.
But this paper hints at something much deeper,
Mm-hmm.
a connection between these two seemingly different approaches.
Exactly. The structured state-space duality paper argues that SSMs and attention might actually be two sides of the same coin.
Wow.
It's almost like discovering a hidden Rosetta Stone that reveals a shared language between these two AI giants.
Okay, now that's what I call an aha moment.
Mm.
How could researchers possibly have missed this connection for so long?
Sometimes the most profound insights are hidden in plain sight.
Yeah.
This paper focuses on a specific type of SSM called a scalar identity SSM,
Okay.
and they show that mathematically these SSMs can be directly translated into a specific form of attention and vice versa.
Hold on. Scalar identity SSMs. My brain needs a little help catching up. Can you break that down a bit?
Imagine you're analyzing a series of events like stock prices over time.
Okay.
A scalar identity SSM would track how each event influences the next,
Mm-hmm.
but it would do it in a very streamlined way, focusing on the most direct connections.
Right.
The paper shows that this streamlined approach can be represented using the same mathematical framework as attention, where the focus is on identifying the most relevant pieces of information.
So it's like both approaches are ultimately trying to achieve the same goal, understanding how different elements within a sequence relate to each other,
Yeah,
but they're coming at it from different angles.
that's a great way to put it.
Okay.
SSMs build up their understanding step by step, efficiently tracking how information flows through the sequence.
Mm-hmm.
While attention, in a sense, takes a more holistic view, directly honing in on the key connections.
Gotcha.
But this paper suggests that those two viewpoints might actually be converging.
That's pretty mind-blowing. And if I'm reading this right, this connection isn't just theoretical. They actually built a new AI architecture based on this duality, right? Enter Mamba 2.
Yes. Mamba 2 is like a fusion of the best qualities of both approaches.
Okay.
It combines the efficiency of SSMs with the expressiveness of attention.
Interesting.
Imagine a note taker who can instantly jump to any relevant section of their notes, no matter how far apart, without losing track of the overall flow.
So Mamba 2 is like a super-powered note taker who also happens to be a master of organization and recall.
Exactly.
I like it.
And that translates to some pretty impressive performance gains.
Okay.
The paper shows that Mamba 2 outperforms both the original Mamba and even some vanilla attention models on tasks that require both efficiency and long-range understanding.
Wait, so it's not just theoretically neat?
Yeah,
It actually works better in practice. That's a big deal.
it is.
What kind of tasks are we talking about?
They tested it on a particularly tricky problem called the multi-query associative recall task, or MQAR. It's like being given a jumbled list of ingredients and having to recall them in a specific order based on a recipe.
Even for a human, that sounds challenging.
It is.
So this MQAR task really pushes the limits of how AI can process and remember information.
It does.
Okay.
And traditionally, SSMs haven't performed well on these types of tasks.
Mm-hmm.
They tend to struggle when they need to hold a lot of information in memory and make connections across long distances.
Right.
But Mama 2, with its ability to combine efficient memory management from SSMs and targeted attention, was able to handle it beautifully.
This whole duality thing is starting to sound less like a theoretical curiosity and more like a potential game changer in AI.
It really is.
Yeah.
It's not just about Mamba 2, it's about the possibilities this discovery unlocks for the future of AI.
Right.
If we can unify SSMs and attention, what other seemingly separate areas of AI might also be deeply connected?
Right.
What hidden links are we yet to uncover?
Those are some seriously thought-provoking questions. But before we get lost in the future, let's dive a bit deeper into how Mamba 2 pulls off this amazing feat.
Okay.
What are some of the key innovations that allow it to outperform traditional approaches?
One of the key innovations lies in how Mamba 2 handles the computational heavy lifting.
Okay.
It leverages something called semi-separable matrices, which I know sounds a bit like mathematical jargon,
Yeah.
but trust me, it's pretty cool.
All right, you've piqued my curiosity.
Yeah.
Semi-separable matrices.
Oh.
I'm all ears.
Okay.
But remember, explain it to me like I'm 5.
Imagine a giant spreadsheet with rows and columns of numbers.
Okay.
A semi-separable matrix is like a special kind of spreadsheet where the numbers are arranged in a way that makes calculations super fast. It's like having a shortcut for doing math.
Okay, I'm starting to see why that would be useful in the world of AI. Where
Yeah.
you're constantly crunching massive amounts of data.
Exactly. And the paper shows that SSMs can actually be seen as operating on these special types of matrices. This connection helps explain why SSMs are so efficient, especially when dealing with long sequences.
So it's like SSMs have this secret weapon that allows them to process information in a streamlined way.
That's a great analogy, and Mamba 2 takes full advantage of this.
Okay.
It also introduces some clever tricks like parallel projections. It's like having a team of super fast calculators working together on different parts of a problem simultaneously.
So not only is each calculation faster thanks to these semi-separable matrices,
Right.
but they're also dividing and conquering the problem to get it done even quicker.
Precisely. And this makes Mamba 2 incredibly efficient,
Yeah.
especially when training on those massive data sets that are becoming the norm in AI.
All right, so we've got efficiency covered. But what about the expressiveness side of the equation? How does Mamba 2 leverage the power of attention to understand those complex long-range relationships within data?
So Mamba 2 incorporates something called masked attention. Imagine you're reading a book and want to focus on the most important sentences to get the gist of the story.
Right.
Masked attention is like putting a highlighter on those key sentences while ignoring the rest.
Okay, that makes sense. So it's not just about paying attention.
Right.
It's about paying attention selectively.
Exactly.
It's like filtering out the noise to focus on the signal.
Exactly.
Right.
This allows Mamba 2 to capture those long-range dependencies in sequences without getting bogged down by irrelevant information.
Now, earlier you mentioned that Mamba 2 is great at handling variable length sequences. That always seems like a bit of a headache with traditional AI models.
Right.
Can you elaborate on how Mamba 2 solves that problem?
Think of it like this. Imagine you're trying to analyze a collection of text messages
Okay.
and compare them to a novel.
Right.
With traditional models, you'd have to chop up the novel or artificially pad the text messages to make them the same length.
Yeah.
It's clunky and inefficient.
Right. It's like trying to fit square pegs into round holes.
Ex-
Not ideal. So how does Mamba 2 handle this mismatch in sequence lengths?
Mamba 2 has this amazing ability to process a batch of variable length sequences as if it were a single continuous stream of information.
Wow.
It's like having a reading speed that adjusts seamlessly to whether you're skimming a news article or diving deep into a textbook.
That's incredible. It makes Mamba 2 so much more flexible and efficient for real-world applications where data rarely comes in neatly packaged uniform lengths.
Absolutely. This is a huge advantage, especially for tasks like natural language processing, where you're dealing with texts of all shapes and sizes.
So we've talked about efficiency, expressiveness, and flexibility. But let's get down to brass tacks. How does Mamba 2 actually perform?
Yeah.
You mentioned it aced this MQAR test.
Right.
But what about other applications?
The paper shows that Mamba 2 also excels in language modeling,
Okay.
which is like the foundation for a whole range of AI applications, from chatbots and text generation to machine translation and even code generation.
So language modeling is essentially teaching AI to understand and generate human language.
It is.
It's a pretty fundamental challenge in AI, right?
It is. And Mamba 2 is showing some very promising results.
Okay.
In their tests, it achieved better performance with fewer parameters compared to some of the leading language models out there.
Wait, better performance with fewer parameters. That sounds like a double win.
Mm.
Doesn't that usually mean it's also faster and more efficient to run?
You got it. It means Mamba 2 can achieve state-of-the-art results without needing the same massive computational resources as some of its predecessors.
Okay.
That's a big deal, especially as we're seeing this trend toward larger and larger AI models that require enormous amounts of energy to train.
This is getting me really excited about the potential applications of Mamba 2.
Yeah.
Are researchers already exploring how to put it to work in real-world scenarios?
Absolutely. Its efficiency, expressiveness, and flexibility make it a very attractive option for a wide range of tasks.
Right.
We're already seeing interest in applying it to areas like natural language processing, time series analysis, and even robotics.
It sounds like Mamba 2 could really shake things up in the AI world.
It has the potential to do just that.
Cool.
But remember, this is still early-stage research.
Right.
There are still many questions to be explored and challenges to be overcome.
That makes sense.
Yeah.
Every groundbreaking discovery opens up a whole new set of questions. What are some of the areas that researchers are still grappling with?
One of the key challenges is figuring out the optimal balance
Okay.
between the SSM and attention components within Mamba 2.
Right.
How much emphasis should be placed on efficient memory management versus flexible long-range analysis? That's something that researchers are still fine-tuning. It's like finding the perfect recipe, a pinch of this, a dash of that, to achieve the best performance for different tasks.
So there's no one-size-fits-all solution.
Right.
It depends on the specific problem you're trying to solve.
Exactly. And that's what makes this research so exciting. There's
Yeah.
so much room for exploration and innovation. Another area for future research is exploring different types of structured masks within the attention mechanism. Remember, we talked about how masked attention helps Mamba 2 focus on the most relevant information.
Right.
Well, the way that masking is done can significantly impact performance.
So it's not just about what you pay attention to,
Yeah.
but also how you pay attention. That adds a whole new layer of complexity.
It does. Designing these masks to optimize Mamba 2's ability to understand specific types of sequences, like natural language versus musical notes, is a rich area for exploration.
This is giving me a serious case of future curiosity.
Yeah.
What are some of the broader implications you see emerging from this research on SSM's attention and their unexpected connection?
This research could fundamentally change how we design and train AI models.
Okay.
It opens the door to a new generation of hybrid architectures that combine the strengths of multiple approaches.
Right.
It's like realizing that two seemingly separate fields of knowledge actually share a common foundation. You know, changes the whole landscape of how we think about the problem.
It's like discovering a hidden bridge between two continents.
Exactly. And that bridge could lead to breakthroughs in a wide range of AI applications, from natural language processing and machine translation to time series analysis and robotics.
It's like a domino effect of innovation. This duality idea could spark a whole wave of new research and development.
I think so too.
Yeah.
This could be the start of a very exciting chapter in AI.
Wow. This deep dive has been a wild ride. We started with these two seemingly separate approaches to AI, SSMs, and attention. And we ended up discovering this hidden connection that's reshaping how we think about building intelligent systems.
It really highlights the power of fundamental research and how even seemingly theoretical breakthroughs can lead to practical innovations with far-reaching implications.
It really makes you wonder what other hidden connections are out there just waiting to be discovered. But as we celebrate these advancements, we also have to be mindful of the broader impact AI is having on society.
Absolutely. As AI systems become more sophisticated and integrated into our lives, it's crucial to consider the ethical dimensions of these technologies.
One of the concerns that often comes up is the potential for AI systems to perpetuate or even amplify existing societal biases.
This is a valid concern, and it's something that researchers and developers are actively working to address. AI models are trained on vast amounts of data, and if that data reflects societal biases, the AI system can inadvertently learn and reproduce those biases.
So it's like teaching a child by showing them examples. If the examples are biased, the child might learn to be biased as well.
That's a good analogy.
Yeah.
It's why it's so important to be mindful of the data we use to train AI systems. We need to strive for diverse and representative data sets that reflect the complexity of the real world.
And it's not just about the data, right?
The algorithms themselves can also be designed in ways that either mitigate or exacerbate bias.
Right. Researchers are developing new techniques to make AI algorithms more fair and equitable.
Okay.
This involves carefully considering how the algorithms are designed, how they are trained,
Right.
and how they are evaluated to ensure they are not perpetuating harmful biases.
So it's like building a house. You need to make sure the foundation is strong and that the materials you use are sound.
Right.
Otherwise, the whole structure could be compromised.
Exactly. Building ethical and responsible AI systems requires a holistic approach
Okay.
that considers both the data and the algorithms.
This also brings up the issue of transparency. As AI systems become more complex,
Right.
it can be hard to understand how they make decisions.
Yeah.
This lack of transparency can be problematic, especially when AI is used in high-stakes situations like healthcare or finance.
Transparency is crucial for building trust in AI. If people don't understand how AI systems work, they may be hesitant to use them, or may even distrust their outputs.
Makes sense.
Researchers are working on techniques to make AI more explainable so that we can understand the reasoning behind their decisions.
It's like having a black box that spits out answers without any explanation.
Yeah.
You might be happy with the answer, but you're left wondering, how did it get there?
Exactly. We need to move away from the black box model
Yeah.
and towards AI systems that can provide insights into their decision-making processes.
Okay.
This is essential for building trust and ensuring that AI is used responsibly.
This whole conversation makes one thing crystal clear. Advancing AI is not just a technological challenge. It's a societal one.
It is.
We need to be having these conversations about ethics, bias, and transparency
Right.
alongside the technical advancement.
I completely agree.
Yeah.
We need to ensure that AI is developed and deployed in a way that benefits all of humanity. This requires collaboration across disciplines, from computer scientists and engineers to ethicists, social scientists, and policymakers.
It's like navigating a ship through uncharted waters.
Yeah.
We need a skilled crew with diverse perspectives to chart a safe and ethical course.
Well said. The future of AI is not predetermined. It's a future we are actively shaping with every decision we make.
Right.
Every line of code we write and every conversation we have.
This deep dive has given us a lot to think about. We've explored groundbreaking research that's blurring the lines between seemingly distinct AI approaches.
Yeah.
And we've grappled with the complex ethical considerations that come with these advancements.
Right.
It's clear that the journey of AI is just beginning. And it's going to be an incredible ride.
It's a journey filled with both opportunities and challenges.
Yeah.
And it's a journey we must undertake together.
Right.
With a shared commitment to building a future where AI benefits all of humanity.
That's a perfect note to end on. Thanks for joining me on this deep dive.
It's been a pleasure.